This is the analysis of the Turning Point lab. First you have the diagram of the pendulum whose length is L, okay, and you're going to change that in the lab, right? And now you set it at the horizontal direction, 90 degrees from the vertical, and then you let it go and make it move, and then you go down to the bottom. When you first let it go, you have maximum potential energy. At the bottom here, all the potential energy turns into kinetic energy. Now, a distance d below the support of the pendulum, you have a peg. When the pendulum string hits the peg, now the pendulum is going to move around a new radius, r, and it's going to go around a smaller radius. And if the peg is low enough down, if d is big enough, then you observed in your lab that the bob goes in a circle around the peg and it just wraps around. If d is too small, that means if the peg is too close to the support, then the pendulum doesn't go all the way back up and it just kind of flops around. Okay, and the point of this lab is to find out what is the minimum length d of the peg that allows the pendulum to go wrap around. Okay, and you want to find that for different lengths of the pendulum. In order to do that, you need to do two things. First, you need to determine what is the velocity of the pendulum bob when it reaches point 3 here. So point 1 is where you release the pendulum and it has 0 velocity. Point 2 is when it reaches the bottom of the trajectory, and this has the maximum velocity. Now as the pendulum goes back up, there's no energy lost because the rope is pulling perpendicular to the direction of the motion, so it's just changing the direction without robbing the pendulum bob of energy. So using energy arguments, you can determine what the velocity is at point 3. So let's do that first. Okay, look at the table at the bottom here. At position 1, your potential energy is mg times L. The 0 point of the energy is at point 2 here. Now, since the pendulum bob is at a height L above this reference point, the potential energy is mgl. The kinetic energy is 0 because it's not moving. Now at position 2, right here, okay, the potential energy has become 0, and all of that potential energy, mgl, turns into 1/2 mv2 squared. Now we don't really need to know this velocity. What's important is point 3, position 3. Okay, when the pendulum string hits the peg and the bob wraps around the peg and it reaches point 3, the potential energy is mg times 2r, and the kinetic energy is whatever is left over. That would be mgl minus mg2r, and you set that equal to 1/2 mv3 squared, and then solve for v3. Okay, we'll use this result later on, but let's move on to the next slide. Now, to continue with this problem, we have to now do a free body diagram analysis and ask the question, will the bob wrap around the peg? In order for that to take place, we have to analyze the forces acting on the bob. At the top of the motion around the peg, this free body diagram is represented right here. Okay, there's a gravitational force mg, and there's a tension force pulling the bob down, T, and that's the net force. F net equals mg plus T, and that has to equal to the centripetal force because the motion of the bob around the peg is circular motion. Okay, now the thing you have to realize is that the smallest possible value of T is 0. So the smallest possible value of net force is mg plus T, which is mg.